Now, a negative externality effect that is uncorrected, just left alone, is going to irritate people, or it's going to injure people, or it could even kill people to the extent that dangerous chemicals are, for example, leached into groundwater that then might have long-term deleterious effect on people's health and might even lead to early death. That would be an extreme case, but it's certainly in line with some of the nasty levels of pollution that sometimes occur in, or have occurred in the past. And these are effects upon others who had no role in the activity whatsoever. So these are individuals who may not even be purchasing the good or participating in producing the good. They're not even involved in the activity at all, but they're being negatively affected as a result of the behavior of others. All right, now I want to highlight a little bit about the ethics of this. Polluters are not good neighbors. You don't want to live next to a polluter. And oftentimes, but not always, polluting firms or even consumers who pollute to some degree don't care or consider how their activities affect others. That's not a very good characteristic that most people would decry and would point out to people and say, you know, this is not a good way to behave. And in saying that, they're making a statement about ethical behavior and what's appropriate in a particular society, especially a society where people are living in close quarters with each other, in cities, where people are bumping into each other all the time and having impacts, both positive and negative. So what would ethics suggest in this particular circumstance? It would say that it's a good idea to be a good neighbor to each other, and that means being willing to work towards a compromise solution when your activities in production or consumption are having negative impacts upon others. Now, one response might be to be a good neighbor means you should just stop polluting. You know, you shouldn't pollute at all because, you know, if you're causing a negative impact upon me, my preference would be to have none of that impact at all. So I might prefer that you just stop, cease and desist, don't pollute at all. But what we're going to see today is that that's not necessarily the best outcome, because the production activity is creating value for individuals as well. And so what's going to become critical here is how do we weigh the positive benefits of production and consumption, all the happiness bursts that are being created because people are trading this good and using it to their benefit. How do we balance that against the negative impacts that are coming or being caused to other people who are not participating in this particular market? It's going to be a balancing act that has to be made and considered. And that's why I'm saying being a good neighbor means being willing to recognize the negative effects that your activity might be causing and to work towards a compromise solution of some sort. It may not mean stopping completely that activity, but it is likely to mean, again, reducing the activity to some degree or trying to clean up the negative impacts that you're having so that it has a less of a deleterious effect upon others. Okay, so let's see what we mean by that. All right, we can't do anything in economics without a diagram. So here's our diagram. We're going to imagine the market for gasoline. And I've got it right here, gasoline. All right, and we've got a supply of gasoline in the marketplace, the demand for gasoline in the marketplace, and we've got the intersection of supply and demand right here in the middle, which determines what I'm labeling PPVT and QPVT. And PVT means private or free market. We could have listed it as FM for free market price and free market quantity. And this is what would happen if we just leave the market alone. Let people do what they want to do. The price should adjust to satisfy the equalization of supply and demand, and we should end up with a price of gasoline at P and the quantity at QPVT. Okay. Now, we're going to add in this non-perfectly competitive assumption. We're going to say, let's suppose that the consumption of gasoline, and I'm going to just focus on consumption here, but it really doesn't matter because the intervention that we're going to evaluate in a minute or two is going to be independent of whether it's the consumption of gasoline or the production of gasoline that's causing the negative external effects. But here, let's just assume that it's consumption. It's driving your car around. It's causing pollution in the local community, and that's having negative external effects upon others in the local community. And in this case, what are those negative effects? It's going to be health-related effects, no doubt, because pollution is going to cause, people with asthma or breathing conditions or problems of that sort are going to have more problems because of the irritants that are in the air around them. And so there might be higher healthcare costs, might be more hospitalizations, there might be earlier deaths. There's all sorts of negative impacts that can be affected on society because of the use of gasoline and the pollution that's caused in the local area. It can also have, it also dirties up buildings. I mean, pollution causes the sides of buildings to look pretty ugly over time. And a building that sits in the city for 50 years often ends up streaked with different amounts of pollution that's accumulated over the years. Okay, so it can have that kind of negative impact on the appearance of the city as well. Okay, so let's just imagine that it's the production and consumption that's causing these negative effects. Oh, I'll make one other point here. The reason why it doesn't matter whether it's consumption or production in our analysis here is because the production level and consumption level are always going to be the same when you're not open to international trade. In that case, production in trade, production and consumption locally might be different. Okay, and then we'd have to specify which of these activities is causing the negative effects. But in our case, production and consumption in the domestic economy is going to be the same because we're not open to trade, and so the statement is valid that I'm making. All right, that's a little bit of an aside. That's not too important, but I'm just emphasizing the details. Okay, now I'm going to define a term called social cost. And social cost is going to be the summation of the private marginal cost of producing this particular product, gasoline, for the local market, plus what we're going to call the externality costs. Okay, and in a sense, we're going to have two different types of costs that we now want to keep track of. Now, remember that the supply curve is the summation of the marginal costs across all of the individual firms. I put the -1 up there to indicate it's the inverse of the marginal cost because it's the quantities that are produced at each individual price that might prevail. But remember, it's just basically the supply curve in the market corresponds to the marginal cost of producing that particular product. And remember, its position up or down determines how costly production of that good is. So as the supply curve shifts upward, we would say that the costs of producing that good are increasing. And if the supply curve shifts directly downward, then we would say it's becoming cheaper to produce those particular goods. So that's why the supply curve, being the summation of marginal costs, is indeed our measurement of the private marginal costs that must be incurred in order to produce this particular product at different quantities at different prices. All right, now, we've got a social cost function listed here, and notice that it is shifted upward. And what we should imagine is that this shift upward corresponds to the externality costs. And in fact, what we're going to do is to imagine that this shifts up, that the externality cost per unit is going to be constant at every level of output. And that's why the social cost function, we're going to imagine for simplicity, is shifting up and is parallel to the original supply function. Now, in a real world situation, it could be more complicated than that, but that's going to mess up our analysis, make it a lot more difficult to do, and it's not really going to change the nature of the result that we're trying to present here. It's not going to change the principle that we're trying to get at. It would change our measurement of things, but it wouldn't change the principle. So keep that in mind. So this shift upward, this vertical distance right here between the social cost, that's SC, and the supply curve, S, is the externality cost, again, per unit consumed. They have to keep that in mind. It's not the total externality cost, it's the externality for each unit of gasoline consumed. All right, so that if we want to get the total market externality effects, we're going to have to multiply that cost by the total level of consumption or production of the product that's taking place in the marketplace. Okay, we're going to see that in just a minute. Now, the social cost function then, this SC up at the top, is taking all of the costs into account. And it's a way of representing on the graph itself all of the costs to society, both internal to the market and external to the market that are taking place. It's going to provide us for a solution to the problem of what's best for society, okay? And here it is. the intersection of the marginal social cost, which is the social cost function, with the demand curve, which, remember, represents the marginal benefit of consumption of the good. Now, what we're doing when we equalize supply and demand is we're equalizing marginal cost with marginal benefit. Well, that's where the private solution is found. But now we want to add in the externality cost and measure the marginal social cost, which is incorporating both the cost of production plus the cost that's being incurred externally, that's being caused to people outside the market. Okay, and that's going to be the marginal social cost then, which when it corresponds or intersects with the marginal benefit, the demand curve, is going to do this. It's going to determine the socially optimal or optimum output level, which we're now going to label here on the diagram Q social for the quantity that should be produced for the society overall. And I'm going to stop right there, okay? That's where the quantity should be. And we're going to see in a minute why that's the quantity that should come about and why that really is the optimal level. But here's the first result I want to suggest from this. If we take that as a given, that this is indeed the social optimal, then notice that the quantity produced under the social optimum is less than the private quantity produced by the firms if they ignore the externality effect. Okay, and that means that the free market production level, QPVT, is greater than what's best for society overall. That's why we would say that the tendency of the private market is to overproduce the good which causes this negative external effect in the rest of the economy. All right, so that's our first result. The presence of a negative externality is going to tend to cause private producers and consumers to overproduce and consume the specified product. Okay, so that's the outcome. Now we want to see if we can come up with a solution. So if the private market tends to overproduce, how could we get the market to the right level? How do we get to Q social? Well, here's an opportunity or an option. We know already that it's possible for the government to adjust how much is produced and consumed in a particular market, and they can do that with taxes and subsidies. And so what we're going to do is we're going to imagine that the government measures both the private costs to the market, to the firms, and they have measured the social costs and can actually construct a diagram much like we've constructed here. In knowing that, they can try to set a tax. And they want to set a tax such that it actually reduces consumption to the level Q social. Okay, so how could they do that? How do we get the quantity to drop from QPVT to Q social? Well, the answer is a tax, but it's a specific tax we want to get. We want to get a tax that's going to generate this quantity level, right? And in order to do that, we basically move to the quantity we want, and we find the distance between the original supply curve and the original demand curve at that Q social. Okay, I'm looking at the demand curve here, not the social cost. Okay, we know Q social is what we want, so find a tax that's going to generate this difference in prices between the two goods. Well, what tax is that? That's going to be a tax that's equal to this distance right here. Okay, and so here's what I've done. I've said, let's set the tax T at this distance, PC social minus PP social, where the PC social is found as the intersection of the social cost function and the demand curve. And the PP is found by going directly down and finding what price would have to prevail for private suppliers to supply the quantity Q social. Okay, so the tax is going to get you there. The tax will achieve the social optimum. Now notice what happens. Because of the tax being put into place, consumer price, we know from before, is going to get bid up. And as a result of that increase in the consumer price, consumers are going to move along the demand curve and consume less. So consumer price rises, demand falls. The tax is going to reduce the price to producers. And as a result, producers are going to slide down their supply curve and supply less. So producer price falls and the supply falls as well. These two, in the end, are equal to each other at the level Q social. Okay, now let's do the analytics. Let's figure out what the impact of that particular tax is going to be. Here things get a little bit complicated, but we just have to keep track of what we're trying to monitor and measure from the diagram that's being represented here. And that's what we're going to do. So the first thing I'm going to do in calculating the welfare effects is kind of look at the externality issue at hand, because we've already done the tax analysis already. And we're going to superimpose the tax analysis with the externality effect analysis in order to get the total impact in the market. All right, so first, I want to talk about the externality effect before the tax. Now, to do that, I do want to start out by saying, okay, suppose we have the private price prevailing and the private quantity prevailing at the intersection of the free market, at the supply and demand curve. If we were to ask what is market welfare in that particular circumstance, with the externality present, we would do the following. We would say at that price, consumer surplus is given by this area right here, right? Producer surplus is given by this area here. And so that area in red that I've just highlighted here is going to be the total amount of well-being created because producers and consumers are trading gasoline in the marketplace. The consumers are getting surplus because they're using the gasoline and it's generating pleasure for them. The producers are getting surplus because it's generating some short-term profits for them and they're making money and paying their employees. And so both sides are benefiting in the market because of the production of that at the private level. Okay, but that production and consumption is causing pollution. Now, how much? Pollution per unit produced is given by this distance right here, the distance between the social cost curve and the supply curve in the marketplace. The quantity consumed and produced in the free market equilibrium is given by this distance right here. So if we multiply the external cost per unit, which is this distance, and multiply it by the number of units produced and consumed in the free market equilibrium, we're going to get this area right here. So the green area, the externality effect before the tax, is the green area on the left-hand side. And so that's going to be D plus E plus F plus C plus G plus H plus A, all of that. And it's negative. Okay, the externality effect before the tax is that this is causing distress to people in the community. And so what we have to do to measure the overall welfare in the economy before the tax is put into place is to take the red area and subtract off the green area. The red is the benefits that are accruing to producers and consumers. I should have made those green because green is positive. And then I should have made the area for the externality effect red because that's the negative. So the red is positive here, sorry. So the red is going to be the benefits that are accruing. The green is the detriments that are caused externally. You take the red minus the green area and you've got the total effect in terms of happiness generation to the community overall at the free market price and the free market quantity. Okay, but now what happens when we move to after the tax? Okay, when the tax is imposed, let me just focus on the externality effect after the tax. Because when the tax is imposed, the quantity reduces to Q social, right? Okay, so the quantity is going to be Q social. And that's going to mean the area that represents the externality effect after the tax is going to be given by this area right here. Here's the vertical distance representing the cost per unit of production or consumption. And here's the quantity of consumption that takes place after the tax is imposed. Okay, so it's going to be area GHIJ, which is actually going to be the cost that's going to be generated after the tax is implemented. Okay, so the cost is still there. You're still having this negative effect upon individuals in the community, but it's not as big of an effect. You know, clearly this red area is smaller than the area we had highlighted before, which was this area here. And in fact, I could see that clearly if I just raise up this red area and note that this G, H, I, and J is going to be exactly equivalent to this area right here, which is D, E, G, and H. I won't get into the proof of that necessarily, but it is true. All right, and D, E, G, and H is clearly smaller than D, E, F, G, H, A, and C, this whole area. So what you're changing, the externality effect after the tax is going to be, let's say, G plus H plus I plus J. And again, it's a negative effect. And that's going to be equal to the equivalent, which is going to be D plus E plus G plus H. Okay, so those are the same. And this is the negative effect after the tax is implemented. It's reduced by area FCA, we're going to see in a minute, and that's going to be the change. So if I actually look at the change and say, okay, well, let's take this area here, which is before, here's the area after. The D's are the same, the E's are the same, the F's, no, not the same. The G's are the same, the H's are the same. And so what we're going to end up with is that the externality effect, the change, is going to be a positive F plus C plus A. And again, we can see that by looking at this area here is the new area. This area here is the old area. The change is FCA. Now notice the change is positive because what you're doing is originally you have a big negative effect. Let's say minus 100 units. Now, when you put the tax into place, you've got a smaller negative effect. Now it's minus 75 units, let's say. So if you move from minus 100 to minus 75 because of the tax, what's the change? The change is a plus 25, right? You're increasing your welfare because you're reducing a cost. And that's what's going on with a tax that's affecting the pollution of a particular item. Okay, now let's put it all together. Now let's talk about the welfare effects in total. Because when you put the tax into place, you're changing producer and consumer decisions, you're changing the quantity. That means you're going to change consumer and producer surplus. The government's going to collect some revenue, which means they've got more revenue to spend on public goods. That's going to benefit some people, taxpayers in the meantime. So you've got to now evaluate all of these costs and benefits simultaneously to see what the total impact is going to be from the tax to correct for this negative externality. Okay, so let's do it. Now remember, original price and quantity is PPVT, QPVT. New prices, the price for consumers is going to be PC social, the price for consumers is PP social, and the quantity is going to be reduced down to Q social. So we ask, what is the change in consumer surplus? Well, consumer surplus originally is given by this dotted triangle. Consumer surplus afterwards is now given by this area here, this solid triangle. So the change is going to be minus, consumers are losing because they have to pay a higher price, it's going to be minus G plus H plus A. Now, what is the change in producer surplus? Producer surplus at the private equilibrium is given by this solid red area. Producer surplus afterwards is going to be given by this area here. Production has, the price for producers has fallen to PP, and the supply curve is here. So we still use the original supply curve, demand curve to figure out changes in producer and consumer surpluses, all right? But what we're going to get is a smaller area of total welfare for producers. So how much are they losing? They're losing because the price is going down, and they're going to lose minus I plus J plus B. Okay, minus in parentheses, so it's minus I minus J minus B. So consumers and producers are both losing as a result of the tax that's being put into place. This is the same analysis we did earlier, a few weeks ago. Now, the government revenue. The tax is given by this distance right here. The level of the tax is applied to is on consumption or production, which is going to be this distance right here. So the government revenue that's going to be collected is going to be equal to plus area G plus H plus I plus J. Okay, so that's what's happening to the market because of the government intervention with the tax. But now we want to evaluate what happens externally because of the correction, the elimination or the reduction, I should say, of pollution taking place in the marketplace. I go back one slide and notice that the externality effect here was plus F plus C plus A. So let's just include that now. The externality effect is going to be a plus F plus C plus A. That's the positive benefit of reducing the pollution. Okay, the change in market welfare now is we're going to add all these numbers up, and we're going to get rid of the areas that balance each other. So notice we've got a minus G up here and a plus G there. So they're going to cancel. We've got a minus H here and a plus H here. They're going to cancel. I've got a minus A here and a plus A over here. They're going to cancel. What else have I got? I've got a minus I here and a plus I there. They're going to cancel. I've got a minus J and a plus J. They're going to cancel. So what am I left with? I'm left with an F plus C minus B. F plus C minus B. Let's take a look at the graph. My positives are F right here, plus C, which is this area here. So F and C. And then we're going to subtract off area B. I'm going to subtract off this area, red. Now, that looks indeterminate. I mean, we can see on the graph that F and C together look bigger than B. But just because it looks that way on the graph might be just a matter of the numbers we plugged in, and we can't be sure of that just by looking at those. We'd have to know the values of these things. And then we'd have to do it in general to be sure whether it's a positive or negative effect. But actually, from the geometry of this particular diagram, we can make an inference here. And the inference I'm going to make is to note that area B, which has a height given by this distance right here, is actually the same height as that distance right there. And this horizontal distance there is the difference between Q social and Q private, is the same horizontal distances up here. So what we can infer from the geometry of this is that F is equal to B. And because F and B are equal to each other, they cancel out, and we are left with a change in market welfare equal to plus C. By putting the tax in place at the appropriate, what we call here the optimal level, the best level possible, we're actually going to be able to improve market welfare overall. We're going to be able to increase the total amount of happiness that's accruing to the people in this community as a result of putting the government tax into place. That's a pretty important and interesting outcome, because now we actually have a role for government. Government has a reason to be there. Government can actually bring good to society in this particular circumstance. And now we can see exactly how and why that's going to be true. So let's walk through the effects really quickly. Now, we talk about the total benefit here. You'll notice that the total benefit is this area C right here. And since F and B are equal to each other, we could actually, it's actually going to come down to something like the following. The tax by itself is causing a dead weight loss in the economy. We did that with our tax analysis before. If we didn't have the social cost function here, if it wasn't there, if this social cost function wasn't there, and we just said put a tax into place equal to this level right here, what would be the effects overall? You would focus your attention on this area A and B and say that's the market welfare loss that's arising because you're putting the tax into place. So we would say that the government policy is indeed creating a distortion. That's the word I would use here, what economists would use. The tax distorts the equilibrium and changes it from the free market equilibrium. And as a result of the distortion, it causes dead weight losses, which refers to the area, those triangles that are left over, A plus B. Now remember, we use several terms. We call them dead weight losses. We call them efficiency losses. We would call A consumption efficiency loss, B a production efficiency loss. So we've got multiple different terms that get used to describe the same phenomenon that we're reporting here. Okay, so that's the loss that's being caused. That's being outweighed, though, that inefficiency, right? Reducing pollution costs outweighs the tax inefficiency. So we're benefiting by reducing the pollution costs. Now, in a sense, another way in which we can represent those pollution benefits, if you will, is given by that area right there. Okay, the green corresponds to the benefits that are being accrued because you're reducing the pollution effects on the community around you. A and B represents the cost that you're incurring in order to induce that particular policy. But since A and B has to be smaller than the green box here, we end up with a net effect given by area C. So C corresponds to the net total benefit that's going to accrue to society because you're correcting for this market externality effect. Okay, so what do we conclude from that? We can conclude here that a government tax actually raises economic efficiency. Okay, when you correct for the externality appropriately, you actually have the impact of raising up total benefits for society overall. The sum of the benefits exceed the costs that are being incurred. And that also means, secondarily, that the free market outcome is not the most efficient outcome we can have. Free market doesn't give us the best social outcome. If we leave people free to do whatever they want to do, we're not going to get a good outcome for the market overall, and you're going to have people suffering from the deleterious effects of pollution. Okay, so that's our main conclusion here. And our first pass at this is to suggest that government intervention can indeed improve the well-being of the economy and the society when it corrects for a market imperfection, in this case, the negative externality of pollution being caused by production or consumption. But there's a little bit more we have to take note of here. In order to do this evaluation, we've had to imagine that we can measure these costs and benefits pretty accurately. It would be nice to be able to know exactly what the supply function looks like for the market at all different prices that would prevail. But you know what? We really don't have that information directly at our fingertips, and calculating it is pretty hard. We need to know the demand curve too. We need to know how demands are going to change and how the consumer benefits are going to change, what the demand curve looks like to measure the consumer surplus effects. So just even measuring the effects of the tax is a little bit difficult. But then we've got this added concern. We have to measure the externality cost. We have to be able to measure what those negative impacts of the pollution are and to what degree it's affecting different individuals. And we have to be able to put that into dollar terms. You know, I referred to the health impacts of pollution, but how do we measure that in dollar terms so that we can compare it to the deadweight losses, these efficiency losses that are being caused by the tax? It can be done, and economists will attempt to do this, but I just want to highlight the fact that it's not an easy exercise. And it's not easy to get all researchers on the same page to say, oh, this is exactly the cost to all people because of the pollution in the community. You know, some will measure extended hospital stays or early death. Some will measure something else. Others will come up with different evaluations and to make different assumptions about how these costs should play out and how much they're affecting different people. So it's not automatic. We make a lot of strong assumptions when we're trying to develop the principles that if we then take it over and apply it to the real world, we find, oh, well, this is going to be really hard to apply in practice. So in principle, we can understand the implications. In practice, it becomes a whole lot harder to make it happen and to do it right.